am Santhya, Assistant Professor, Department of Biomedical Engineering and Excel Engineering College. So now we are going to take a class, Signals and System. The topic will be classification of signals. So the signals will be classified on based on their natural signals only. So it is classified the different types of signals. So first one is the continuous time and discrete time signal. Second one is the deterministic and non-deterministic signal. Third one is the even and odd signal. Fourth one is the period and aperiodic signal. So fifth one is the energy and power signal. So sixth one is the real and imaginary signal. So this is having the 6 different types of classification of signals. So in here, so what is our first one? Continuous time and discrete time signal. So what is the continuous time? So the continuous time is nothing but the time will be continuous. Okay. So in here, one example is here. If you having the signal x of t, the signal will be a sine signal. So we can define the amplitude value and time interval. So the amplitude will be denoted by the y-axis and the time will be denoted by the x-axis. So the time will be continuous means we can find the at any instant of time. So in here, so we can find the 0.01 value. So we can find the 0.01, the amplitude will be a 1 or some 0.05. So we can find the value of at any instant of time. So the time will be continuous. So it is called the continuous time signal. Understand? So what is the discrete time signal? So that is the discrete time signal is nothing but your. So we cannot determine the value of signal at all the distance only at discrete interval of time. So in here one example is here. So in discrete time signal we are using discrete time signal. So that a discrete time signal will be defined as one determine the value of the signal at all the instant only at discrete interval of time. So it is so in here one example is here. So this is your x of t signals. The signal will be using the discrete signals only. So that is called the increase pulse only. Okay. So in here the amplitude will be continued, but we are using the time period will be constant. Understand? So we cannot find the 0.01 amplitude value. So that is called the discrete signal. So it is the relation between the continuous time signal and discrete time signal. So continuous time signal is nothing but the time will be continuous. In your discrete time signal is nothing but we are using the discrete signals only. Okay. So it is the amplitude will be continuous, the time will be constant. So we cannot find the other values. So 0.1, 0.0.1. So we cannot find the amplitude value of the discrete time signal. So it is the difference between the continuous time period and the discrete time signal. So second one is the deterministic and non-deterministic. So deterministic is nothing but your. So if you are having the signal, so if you are having any signal, so in here is the sine signal. So in here x of t equal to sine signal and also the time period will be t. So we can represent the x of t equal to sine t. So it is called the, so we can represent the mathematical equation. Understand? So we can represent the mathematical equation. So here x of t equal to sine of t. If you have any signal, the signal means sine signal or cos signal, we can represent by using the mathematical equation. Means that is called the deterministic signals. Understand? So next one is the non-deterministic signal. So non-deterministic is nothing but your. So it is one of the random signal. Understand? So what is the random signal? So random signal is nothing but your. So you can having the signals, but we cannot find the mathematical equation. So in here one example. So it is a signal, but we cannot using the mathematical expression. Understand? So that is called the non-deterministic signal or a random signal. Understand? So what is our third one? So it is the difference between the deterministic and non-deterministic equation. Deterministic signal. So deterministic signal is nothing but your. So we can using the representing your signal in mathematical equation. So what is the example? X of t equal to sine. Understand? So in here non-deterministic is nothing but your. We cannot represent in the mathematical equations. Okay. So that is called the random signal or a non-deterministic signal. So what is the third one? So third one is nothing but your even and odd signal. Understand? So what is the even signal and what is the odd signal? So the both signal will be used in the time reversal. So time reversal is nothing but your. So it is having the conditions. Understand? So in here, so third one is the even and odd signal. So even and odd signal is nothing but time reversion. Understand? So even an odd signal is nothing but it is having the time reversal. Understand? So what is the even signal means? So in here it is having the one condition x of t equal to x of minus t. So it is the condition of even signal. So it is nothing but you can draw the one signal here. So this is your signal x of t. So even signal we are using the time reversal. So time reversal means we can draw the same signal in reverse. Okay. So we can draw the reverse means again you can get the same signal. The signal will be same, but your signal reflection of your signal. Understand? So that is called the even signal. So even signal is nothing but a reflection of your signals. So it is having one condition x of t equal to x of minus t. Understand? So it satisfies the conditions means that is called the even signal. So in one example is here. So this is your x of t signals. This is your x of t signals. You can draw the reflection of your signals. We are getting the same signal. So that is mean the even signal. So what is the odd signals? Odd signal is nothing but we are having the conditions. Odd is having the x of t equal to minus x of t. So in here I will draw. So this is your x of t. Understand? So this is your x of t. So you can draw the signal in reverse. Okay. So you can draw the signal in reverse. So we cannot get the same signal. So that is called the odd signal. Okay. So both even and odd signals using the time reversal. So even signal is nothing but it is satisfy the x of t equal to x of minus t conditions. So it satisfies the condition means that is called the even signal. So odd signal is nothing but so this is also using the time reversal x of t equal to minus x of minus t. So it is satisfied this condition means that is called the odd signal. So what is our fourth one? So fourth one is nothing but periodic and aperiodic signal. So what is the periodic signal? So periodic signal is nothing but if the signals are going with a particular period. So particular period means that means nothing but time period. Understand? That signal is called the periodic signal. So periodic signal is nothing but if you having the any signals or sin t or a cos t, it is going with the same time period. Understand? So that is called the periodic signal. So here I will draw. So this is your signal. So this is your signal in x of t. Understand? So this is your signal. So the signal is having the same time period. Understand? So the same time period means it is going to the same time period. So it is going to the this level time period will be t and also the time period will be t. This time period will be t. So it is having a same time period. It is going with the same time period. So that is called the periodic signal. Understand? So what is the aperiodic signal? So aperiodic signal is nothing but so it is not going with the particular time period. So what this means? So it is not going with the same time period. We having a different time period. So in here, so it is having a t time period, and here we is having the t by 2 time period. So it is having the difference time period. Understand? So it is having the difference time period means that is called the aperiodic signal. Understand? So what is the periodic and aperiodic signal? The signal is having the same time period means the signal will be going to the same time period means that is called the periodic signal. So aperiodic signal means that signal is not going with the same time period. So it is having the different types of time period. So what is the example? T. So it is one of the t time period and t by 2 time period. So it is having the different type of time period. So that is called the aperiodic signal. Understand? So what is our next signal? So what is our fifth one? So fifth one is the energy and power signal. So energy and power signal is nothing but if you are having any signals. If you are having any signals, so the signals will be of energy means that is not a power signal. Understand? So in here x of t equal to sin. Okay. So this is an example. If you are having the any signal. So x of t equal to sin t. So the signal will be a energy means that is not a power signal. So another one example. So x of t equal to cos of t means the signals will be a power means that is not a energy signal. So it is not satisfying the both condition. So if you are having the any signals, the signals will be energy means that is not a power signals. So if you are having the any signals, the signals will be power means that is not a energy signal. So it is the relation between the energy and power signals. Understand? So what is the sixth one. So sixth one is nothing but your real and imaginary signals. Okay, so what is the real signal? So in here x of t equal to a. X of t equal to a. So a is nothing but your real part. So that is a is nothing but your real signal. Understand? So what is real and imaginary signals? So real part means x of t equal to a. So it is nothing but your real signals. Okay. And also it is having the I or a j imaginary values. So it is having the imaginary values means, so in here I is a imaginary, j is a imaginary. So it is having the imaginary values means, so it is called the imaginary signals. Understand? So the signals will be having the real plus imaginary. Okay. So a is nothing but a is a real signal. I, j is nothing but that is the imaginary signal. So it is called the real and imaginary signal. Understand?